All right, going to continue solving the practice exam questions. So for the inner part 2, we're at question 11, where we were asked to find the distance this car moved from the time the driver saw a cat on the road to the time they stopped. And like I was saying when I was introducing it, there were two parts of the motion that need to be analysed. So let's do it. The first part. So this car's driving along the road at 70 kilometres an hour. So if you like, we'll do this part 1. 70 kilometres an hour. We know we can't use these in our formulas, so let's convert that to metres per second. So we're going to have to divide by 3.6. (19.4 metres per second). Okay, and so he was doing this speed for 0.4 seconds. So V equals delta x over delta t. So 19.4 equals delta x is our unknown, delta t is 0.4 seconds. To get delta x by itself, we multiply both sides by 0.4. So 19.4 times by 0.4 equals 7.78, and that's distance, so it's metres. Alright, so that's the distance of this part here. So let's work out how far he travels while he's decelerating. Call this part 2. So he starts decelerating from this speed. So our initial speed for this section here is 19.4 metres per second. He decelerates constantly at 8.4 metres per second until his car comes to rest. Comes to rest means it stops, so that's final velocity is 0 metres per second. There you go, we've got our three knowns, and our unknown is the distance. We go to our formulas, and we're looking for a formula with u, a, v and x. And we've got u, a, v, x in this one here. So v squared equals u squared plus 2ax. Substitute in our values. And I've just about made a mistake here. So remember, the car is decelerating, so that means that this is going to be negative minus 8.4 times by x. Okay, so let's neaten this up. 0 squared is 0. 19.4 squared is 376.4 plus 2 times 8.4 minus is minus 16.8x. Okay, we subtract 376.4 from both sides, gives us minus 376.4 equals minus 16.8x. To get x by itself, we divide both sides by minus 16.8. That goes with that. Minus 16.8. Therefore, x is going to be equal to 376.4 minus 376.4 divided by minus 16.8 equals 22.4 metres. That's not our final answer, don't forget. That's our answer to how far they travelled in the second part of the motion. So what we need to do is add them together now. So part 3 is to add 7.78 metres to 22.4 metres, which is going to give us 30.2 metres. That's how far the car travelled before it stopped. Alright, that gets us to dynamics. Alright, question 12. A force F acts on an object of mass m to give an acceleration of a. If m is halved and F is doubled, what happens to a? Okay. No numbers have been given to us, just a hypothetical situation. So F, m and a, you should remember that F equals ma. So to determine the difference, we're going to have to just make up some numbers to give us our starting point, and then we'll do what it says here. So if you like, just for round numbers, and they're getting me to half, so I'm going to choose even numbers, makes my life easier. So let's call F of 6 newtons, just because. A mass of, I don't know, 2 kilos, and we'll work out what the acceleration is with this. Okay, 2 times A, if we divide both sides by 2, we have A equals 6 divided by 2 is 3. Okay, so this is our starting point. Now let's make the changes that it wants. If M is halved, alright, and we made M equal to 2, and F is doubled, and we made F equal 6, what happens to A? Okay, so let's do what it says. If M is halved, that means we have a mass of 1 now, and F is doubled. 2 times 6 is 12. Look, I've made my life very easy for myself here. 1 times A is A, 12. A equals 12 metres per second minus 2. Now, comparing this and this, going from 3 to 12, that's an increase of a multiple of 4. Not divided by 4, it's going up. It's divided by 8, no it's not. It remains unchanged, certainly not. It's multiplied by 4, yes. Question 12, the answer is D. What's the magnitude of the net force that makes a mass of 15 kilograms accelerate at 3 meters per second? F equals ma. Substitute our numbers in. 15 times by A is 3 equals 3 15s is 45. What's the magnitude of the net force that makes a mass of that much accelerate by that much? Yep, 45 newtons. Okay, now we get to the tough, really tough stuff, I reckon. This is about as tough as dynamics gets in year 11. So, following information applies to questions 14 and 15. 100 kilogram block of stone, up an incline 15 degrees, friction is 200 newtons. Okay. Draw the diagram of the scenario, labelling these forces: weight, normal, friction, and the force pulling up the incline. Okay. Alright. Our incline's 15 degrees, it told us that. Our block of stone is 100 kilos. And what else did it tell us? Friction is 200 newtons. Okay. And it's being pushed, and I know I say pulled later on, but either way it's moving up an incline. So that's the force pulling it up the incline is F. So friction always opposes the direction of motion. So it's down the slope, F, little f. So we've got that, we've got that. The weight force is always directly down because it's due to gravity. And we've got one to go. The normal force, and the normal force is always at 90 degrees to the surface. So that means it comes out like this. F, N. Alright, they're our forces. Okay. Now, determine the value of F which is this, that will move the block up the incline at a constant velocity. Okay, you see this, and immediately your physics brain should snap into line and say, sum of forces equals 0 newtons. Okay, sum of forces is nothing when there's a constant velocity. So that means the force being applied is overcoming friction, and it's overcoming that bit of gravity that's wanting to pull this block back down the slope. So we know the frictional force is 200 newtons, so that's the first bit I've got to overcome if I want to pull it up the slope. I've got to overcome friction. Now I've also got to overcome gravity. How much acceleration due to gravity is the question. Okay, So force is mass times acceleration. The force required is going to mass is 100 kilos. It's told us that. Now the acceleration. This is the problem. If I was pulling it vertically upwards, then the acceleration would be 10 due to gravity. But it's not going to be that much because it's on an angle. So we need to find out how much, and we can go back to our formula sheet here. Whoops, I've actually left the other part of the formula sheet at school. But on the other formula sheet, you'll find your F equals ma. And then you'll also find, on an inclined plane, acceleration is g sine theta. G being gravity, sine theta, the angle. So that's what we're going to need to find this, and then we can substitute it into there. Okay, so let's take a side step here. We need to find A equals G sine theta, which is 10. I'll use the round number of 10 instead of 9.8. Makes my life easier. Sine, and the slope was 15 degrees, if I remember correctly. It was. Alright. My calculator, 15 sine multiplied by 10. 2.588. 2.59, and that's acceleration, meters per second squared. Okay, now that's what needs to go into here. So now we've got F equals 100 times by 2.59. Right, 100, so I can just move the decimal place 2 places across. 100 times 2.59 is 259 newtons. So that's how much force I'm going to need to apply to overcome the force of gravity on a 15-degree slope for a 100 kilo block. Alright, so now I just add these together. So if you like, sum of forces, or the total force, is going to equal how much frictional force I need to apply, plus the force to overcome gravity, and so we make that that's 200 plus, we found this is 259. 200 plus 259 is 459 newtons. Okay, the total force is 459 newtons. Alright, following information applies to questions 16 to 18. I didn't actually set the stopwatch for this. I don't know how long I've been going for. I'll call it quits. I'll cap this one off, and then we'll come back and we'll start with 16.